First question is about diffraction. The answer should be A, which is an example of diffraction. Obviously, if we can hear sound from the corners, that is due to diffraction, the waves are spreading. The next one is B, the ability to hear sound, a high frequency, low frequency. This thing is affected by pitch, and pitch is not affected by diffraction. And the volume of the sound, which is loud and quiet sounds, this is all affected by amplitude. So amplitude is not affected by diffraction, so this is also not the answer. And the ability to hear sound through a brick wall, this is due to acoustic transparency, means like conduction, and obviously diffraction doesn't happen like that. In question number 2, there is superposition of stationary waves, so we can see different points. The first one says an antinode is formed at the surface of the metal. Basically, they said that the wave formed by superposition of sound waves from a loudspeaker and the reflection from a metal sheet, which is not shown. And antinodes are usually not formed at the surface of the metal sheets. They're usually formed and at these particular peak points, and this is not at the surface, and we are also not sure where is metal sheet actually. So this is not a valid answer. A node is a quarter of the wavelength. This is basically what we know true. It is obviously a quarter of the wavelength because, for an example, if this is the node and this is the antinode, the difference between these 2 points is just about half of the wavelength. Like this is the full wave, and this is, if this is the full wave, and this is half of the wave, and this is quarter of the wave. That's why this is a suitable answer. This should be the easy answer and direct answer. Whenever you see this thing written, you should give this tick. The oscillation at X are in phase at those Y. Obviously, you can see there are different points and they are not in phase. The air particles oscillates. The air particles, oscillates perpendicular. Obviously, they do not oscillate perpendicular. They oscillate parallel to each other. In question number 3, a musical instrument called a bungle is a long tube. Obviously, it's something like tube where the important points are like it says that the mouthpiece part has a node. So this is a node, and the opening part has antinode. So this is very much similar to this type of wave diagram where there is a node and antinode, this one, this pattern, which is a quarter of the wavelength. So according to that, the frequency formula would be NV by 4L. The bungle can produce the lowest frequency of 92 Hz. So this is the lowest frequency, and they asked for the other frequencies. So the lowest frequency can be about when n is 1, and then the next following frequency. And remember, for this type of pattern, all the n values, which is the fundamental frequency, and then the first frequency, secondary frequency, all these values would be odd numbers, like n value 1, then 3, then 5, and then 7. They have all, in all of the options there are about 5, but I don't need all of them, just I need few to match. So how to solve it? We don't have we know the speed of sound, but we don't know the L value or the length of the tube. This is also not necessary. The length of the tube would be same for all of them, so we can avoid the L values and the 4 values. We can just compare between the N and F, because we can see that frequency and the N value are directly proportional to each other. So we can just simply use the unitary method. So like when n is 1, the frequency is 92. So when n is 3, what would be the frequency? That would be 3 times 92. It would give you 276. Again, do the same thing for n5. When n is 1, f is 92. When n is 5, what would be f? That would be 92 times f. That would be 460. And for this one, it would be about 644. So we just use simple unitary methods to solve it. According to that, the answer would be C. Next question is about a monochromatic light which has a wavelength is given. The angle of diffraction is given between the first order maximum, means it's like this is 0 and this is the first order, this is the first order, so this angle between first and second is given 5.4, and this is the first order obviously. So I hope you remember the formula, which is a sine theta equals to n lambda. Now from here we need to find out the value of a, which is the gaps between the diffraction grades. So n lambda by sine theta, if we can insert these values and then find out the value of a. And then if we insert these values, n is 1, lambda is 5.3 times 10 to the power negative 7, and the sine theta, the angle is 15.4. If we do this calculation, that would be about 1.99 is the diffraction grade differences. And then we need to find out the angle of diffraction for second order maximum. So make theta the subject, that would be n lambda by a, and sine verse of this, sine verse n lambda by a. So if you put your values, n is 1 obviously, and lambda is 5.3 times 10 to the power negative 7, and the value of a is 1.99, which is like 2, and sine verse. So if you do this calculation, and yes, if we put these values correctly, the maximum is 2, the lambda is 5.3 times 10 to the power negative 7 as given, and the slit difference we found was 1.99 times 10 to the power negative 6. If we insert all these values, we will get a value of 32 degrees. So this is the other angle, like this much, from for maximum of 2. So they asked for the difference between the two maximum, 1 and 2. So just subtract. If we subtract 32 from 15.4, the value would be about C, 16.7, close to that value. For question number 5, they said a progressive wave is incident normally on a flat reflector. So it's like if I draw it up here, the wave is traveling like this towards a reflector which is flat, and then it reflects and it overlaps with the incident wave, and a stationary wave is formed like this. It gets reflected and a stationary wave like this is formed. Now at any instant at an antinode, like this is the antinode of this is the antinode. At antinode, what would be the ratio of the displacement? Displacement means from the principal axis to the point of displacement, this one vertically, this is the displacement. So basically this is the amplitude. So they're asking for the ratio of displacement of the incident wave, which was the initial one, like this one was the incident one, with compared to the reflected one. And it's very easy and simple that we can easily notice that this displacement of the incident one and this displacement of the reflected one must be same. Means amplitudes are usually same, so the ratio should be 1:1. So answer should be C. Question number 6 says that a wave of speed c and wavelength lambda is passing through a diffraction plate. They asked for the time. We know that time equals to distance divided by speed. The distance covered from GH to point P would be the wavelength, individual wavelength. So this is one wave, two waves, and three waves. So one, two, three. So there should be 3 lambda. Should be 3 lambda by the speed of the wave is c. So it should be 3 lambda c. Answer is this one. In the next question, it is very easy. They asked for how far apart are the two adjacent interference fringes. It means that we are provided with the wavelength, we are provided with the distance between the screen and the diffraction slit, we are provided with the slit differences, we are provided with all the informations we need. The formula to use is lambda equals to ax by d, where if you make x the subject, which is the thing we need to find out, then it would be lambda d divided by a. If you input all the values correctly, you will get your answer in meters, but that should be converted to millimeter. In this question, number 7, um, we not 7, sorry, in question number 8, basically. In question number 8, we are basically provided with what information? A double slit experiment is done, light frequency is given. The fringes difference, the fringes are this much apart, and the distance between the screen and the fringe is not given. So what is the separation of the bright fringes when the frequency of the light is changed to another one? Means initially there was some frequency, so we get this fringe difference. Now if we change the frequency, what would be the new fringe difference? The fact is that there wasn't any formula connecting frequency with this, so we need to convert frequency to wavelength. Like what the initial frequency was this, so we use the normal formula, wavelength equals to speed divided by frequency. We can see that when the frequency was 6 times 10 to the power 14, the wavelength would be 5 times 10 to the power negative 7. And when the frequency is 5 times 10 to the power negative 14, the wavelength would be 6 times 10 to the power negative 7. So we are changing the wavelength from 5 to 6. Now, if we know the formula that can be used according to this point is lambda equals to ax divided by d, and from here the information that we have is the value of lambda and the value of x, the fringe differences. But a, which is the slit differences, and the d, the gap between the screen and the diffraction grating, this thing is not given. So what we do is use the unitary method. We know that by this equation we can notice that lambda is directly proportional to the fringe difference. So we can say when the wavelength was initially 5 times 10 to the power negative 7, this one, that time the fringe difference, was 3 millimeters. And when we change this to 6 times 10 to the power negative 7, what would be the value of fringe difference? We put this as x. If you solve this, you get 3.6 times 10 to the power negative 3.6, and according to that, the answer is D. The next question is about the monochromatic light. You can see they are showing that diffraction. The slit differences are given. The distance between the screen and the diffraction slit is given, and the distance between the fringes are also given. So first thing first is they ask for the path difference. Now by using these informations, we don't find path difference directly. First of all, we need to know, like path difference, we formula is L equals to n lambda for the bright fringes, or for the dark fringes it would be L equals to n plus half lambda. Now we don't know the lambda, so we need to find out the lambda first. So the formula for that is L lambda equals to ax by d, and all these informations are given on the screen. So if put all these values, converting the millimeters into meters, we find the wavelength is about 4 times 10 to the power negative 7 meters. And they asked for the path difference at point of second order dark fringe. Now, if this is the 0, this would be the first maximum, this would be the second maximum, and the dark fringe between the first and the second, it should be 1.5. So if you put 1.5 times lambda is about 4 times 10 to the power negative 7, the answer would be 6 times 10 to the power negative 7. So your answer is C. In this next question, it says we are comparing two types of tubes. One of the tube is open at both end and the other tube is closed at one end and open at the other end. They have different length. One is L and the other one is 2L. And therefore they produces two different frequencies. One is Fx and the other one is Fy. Um, Both of them are in the lowest frequency, lowest fundamental frequency. So we will consider n value to be 1, and the speed of light is what we know. But the fact is, we don't need to input these values to find out the frequencies, not necessary. Where we just have to compare these two frequencies and create an equation. How to do that? Like this one, first one, the formula for both side open should be Fx equals to Nv by 2L. And whereas the second one, the formula for Fy should be Nv by 4L, but here L is 2L, so we will multiply 4 by 2L. That would be Fy would be equals to Nv by 8L, this one. Now we need to input or substitute in place of Nv the frequency of Fx. We have to combine these two frequencies. How? If we make NVL, if we make NVL the subject, the Fx would be equals to Fx times 2, means 2Fx we can say. That would be 2Fx. Just 2 goes up with the frequency Fx. Now you have to input or substitute this value Fx in this equation. So that would be Fy equals to, in place of NVL, 1 by 8 remains. If we take out NVL from there, in place of NVL we will get 2Fx, and then next one, question number 11, which statement gives a condition that enables diffraction? And that is obviously answer B. The wave partially blocked by an obstacle, not completely, partially means a gap. So so now we can see that S and T are at a distance of x, and the relationship between S and T would obviously, we can see that distance between the displacement usually should be same because they are at the same distance apart, so they must have the same differences or displacement, and the phase difference should be of about 180 degree. They obviously are not in phase. It's not possible. They are different in position. So we can't calculate the phase difference, but this is the only option. So we have to choose option C. They don't have different amplitude, obviously. So answer is C. The second one is about a graph of intensity and the distance when Sounds approaches from a mic two speakers at particular point. So microphone is moved from P to Q, and what patterns should be observed. Now remember, the intensities at the dark fringe of the destructive interference, the intensity never falls to zero. In B, you can see it touched the zero line, x-axis. Intensity is zero at that point. No, it's not possible. And D also the same thing, not possible. In C, intensity is quite constant. It decreases, means at every point, at every maxima, the intensities are constant, and that is not possible because at the principal axis, at the zero maxima, the intensity should be maximum. And then if we go on far away, the intensity will slowly decrease. The intensity will decrease. So according to that, answer is A. Number 14 is a similar type of question. We have done it before. They told us to find out the angular separation between them. So what we need to do, we use the formula d sine theta equals 10 lambda. So between the first and the second order, so in the first one for the first theta, we need to n value should be 1, and wavelength is given, and the separation is also given. It's micrometer. Converted it, you have to convert this into meter, and you will get a value in the first one of 17.5, and the second one n value should be 2, and the rest of them is the same thing. Wavelength should be same, 600. It's in nanometer, you have to convert it obviously, and d value is also given. So if you find it out, it would be 36.9, and just subtract them. Your answer should be B. The next question is about which combination will result in visible fringes being observed. Means there are four options. Visible fringes means something that would be visible to human. Means it's possible to see. It's not that much small. The best would be the one that has the largest fringes, largest fringe differences. The more the fringe differences, the more visible it would be. Like if the fringes are too close to each other, it would be very difficult to understand they're separate. But if the fringes are far apart from each other, the more far apart they are from each other, the more visible that would be that these are separate fringes. So I hope you understood that what they want. So which combination will result into the maximum value of x? Maximum value of x, the differences between the fringes. So obviously all the values are given. Just input the values and find out for individual. You can do like that, but that would be lengthy, time taking. So the easiest way of doing this is don't have to do any calculation. Just find out the connection between x and lambda and d and a. Now from here we understand that wavelength is given, so the connection between x and wavelength is that if we increase the lambda, x will also increase because they're directly proportional. So the largest value of lambda is 600, 600. So option C and D, A and B is gone. And then the slit difference. The slit difference is represented by A, and we can see that A is inversely proportional to X, so the lowest value of A would be best. So we see 0 0.1 and 100, so 0 0.1 would be selected, and in D we have 100, so we got our answer, that is C. And still one more is left that is not necessary to do, but still if D is more then X is more, like that this is also matching. So our correct answer is C. Question number 16 is asking about which expression would give the spacing of lines of diffraction grating. The formula for this is d sine theta equals 10 lambda. If you make d the subject, it would be lambda by sine theta. Now, basically, lambda is given. The lambda is actually not given, but the fact is the order, n value is given. It is the second order maximum, so we put 2 here, so we get 2 lambda. And the theta is it is the this theta is the angle between the first second order, the two second order, one is the positive one and the negative one. So we need to find out the angle between the zero order and the maximum order, this one, so that would be the half of this angle. So if you put all these values correctly, the equations would be something like this. Answer is D. The next question is number 17, where they have said that there are two waves P and Q, and initially they superpose. How, like, if I show this up here in my diagram, there is one of the wave which is yellow wave and the red wave. They are in phase but with different amplitude. So therefore, whenever they superimpose, their overall displacement together would be 14. That was given in the question. This is what was written in the question. But then, when the phase difference was changed to 180 degree, which appeared like this, where one of the if P and Q became opposite to each other, so their amplitude becomes opposite to each other. That time the equation turns out like B minus A. The B is bigger than A. B was bigger than A, so the overall resultant displacement is now 4. So that's why I wrote B minus A. B is, if B was in the negative section, if it was A minus B, then the resultant would have been negative 4, but it was positive, so that's why B minus A. Now we get two equations. One is A plus B equals to B plus A equals to 14, and the other one is B minus A equals to 4. So if you do simultaneous equation and by substitution, we will get A as 5 and B as 9. So the value of A and B should be 5 and 9. There is no 9, but there is 5, so the answer is 5. In the next question, number 18, P and Q are the two wave sources. They have a phase difference of 180 degree, and therefore at point S there is a minimum in the interference pattern produced. There is a minimum in the interference pattern produced by the waves from the two sources. So what could be the path difference? We know the path difference is equals to n lambda, and the minimum value is 1. So therefore L should be equals to lambda. Next question, number 19. There are two lasers. One is a red laser with a wavelength of 633 nanometer, and the diffraction grating was given 600 lines per millimeter. And then they changed this red light to a blue laser with a wavelength of 445 nanometer, and they are saying that the distance between diffraction grating and the screen should be same, and the first maximum to zero order, this difference between the fringes, the gap between the fringes x, should be also same. If you use the formula lambda equals to ax by d, up here only a and lambda changes, but x and d remains unchanged, and the value of x and d is also not given, so you will use the unitary method. The connection is directly proportional. Lambda is directly proportional to the a, which is the difference between the diffraction slates. So according to that, when the wavelength was 633 nanometer, the difference between the slits were 1.6 times 10 to the power negative 3. How did I find this out? It is like 600 lines in 1 millimeter. Then what would be the difference for one line? So 1 divided by 600, this is the difference, and this is in millimeter. I didn't change it because it's not necessary. None of the units are necessary to change because the final answer is also given in millimeter. And when I use 633, the distance gap was this much, but when I use 445 blue light, that time how much would be the diffraction slit gap? So if you solve it, you will get 1.7 times to the power negative 3. Now you just divide 1 by this value. You will be able to find out the number of lines that is required. So according to that, I got 855. It is close to 850, so our answer is D. Next one, number 20. Two coherent progressive waves uh, are from different source. Which condition must be satisfied for there to be zero resultant amplitude? If they want to have zero resultant amplitude where the waves meet, then the two waves must have the same amplitude at that point. Obviously, the two waves must have same amplitude at that point. If they have same amplitude, then they will cut off like this. If one wave is like this with 180 degree phase difference and the other one is like this, so if their amplitude matches and a minus b, it'd be 0. Like if it is also 4 millimeter, this is also 4 millimeter, they will cross over to give 0. So the two waves must have same amplitude. Just having a different opposite direction, or if they have different phase, that will not only work, they must have same. This is most important part. And together with that, 180-degree phase difference is also needed, but still most important part is same amplitude. In question number 21, we can see there's a corridor with two closed doors, and they said there will be a node in the middle. So if we draw the patterns of the wave, it would look like this. And this looks, and according to this one, the n value should be 2. When the n value is 1, that time there is no node in the middle. But when there is n value is 2, that time there is a node. There is overall 3 nodes. 1, 2, 3. Now the length is given, so if you use the formula and put all the values which are given to, you will get a value of 25. So therefore, for this one, number 22, which gap width and wavelength would cause the largest decrease in diffraction? For good diffraction, we need bigger wavelength and smaller gaps. But for bad diffraction or low diffraction, we need uh, less wavelength and gap should be more. So accordingly, gap more, wavelength less should be C. Number 23, what would be the distance OY and XY for the person can stand anywhere between this line, in this line, within this line, and the waves from X and Y are in phase, and the wavelength is 0.75. Now the fact is that if the waves are in phase, then the sound waves from X should be also matching with the waves of X or Y, and different variable distances are given for X and Y. So whatever this distance is should be a multiple of this value, means 0.75. As the wave in his phase, the distance between X and Y should be multiple of 0.75. So if you divide this distance xy, it should give a whole number. So if you divide 3.5, it doesn't. 2.75, it doesn't. 2, it doesn't. But only 1.5 divided by 0.75 gives a complete whole number, that is 2 complete waves. You get 2 complete waves. It means this is the correct option. That's why answer is D. If you see question number 24, it's a simple question. Accordingly, if you want to increase the first order intensity maxima further apart, means if you want to according to the formula, lambda equals to AXD, where D is the X is the differences between fringes, the gaps, not the gaps, the distance between the fringes, this distance. If you want to increase this X value, then obviously we have to uh, increase the lambda wavelength, but in option D they said they use shorter wavelength, so it's not correct. Or you can do something like, if you can increase the distance between the screen and the grating, so D would be also equals to AX by lambda, and that is directly proportional, but in A they have decreased that distance, so it's not gonna work too. And in C, option C, they're increasing the grades, but they're keeping the separation same, so it's not gonna work, it's not gonna change anything. But if you make A the subject, A would be lambda D by X, so it's inversely proportional. So if you use a diffraction grating with less separation, if you decrease it, this one will increase, so accordingly B is correct. Next is the theory part. The first question was, what is transverse wave? Obviously, it is the oscillation of particles that is obviously perpendicular to the direction of energy of propagation. Next, state the principle of superposition. Superposition is obviously when two waves of same type meets at a point. That time their resultant displacement would be the sum of their individual displacement. And frequency, amplitude, all these things must be same. Then B, A circular water wave is produced vibrating dippers at point P and Q. The wave P alone have the same amplitude at point R as the wave from Q alone. Distance PR is 44 and distance QR is 29. The dippers vibrate in phase with a period of um, 1.5 seconds to produce the waves for 4.0 centimeter per second. So they are asking for the wavelength. Now, according to this fact, we can find out on the frequency first of all, because the time period is given, and frequency is equal to 1 by t 1.5. And if we know the frequency, we can find out the lambda. Lambda equals to um, speed divided by frequency, and our speed is about 4, and the frequency is 1 by 1.5. If we do this calculation, you will get 6 centimeters. Next question was, by reference to the distance PR and QR, explain why the water particles are at rest at point R. At point R, they are at rest. Obviously, that is because they are having um, destructive interference. It means they are cancelling out each other. The amplitudes are opposite to each other, so it cancels out, so it becomes zero. Now, the path difference between PR and QR is about 2.5 lambda. That is why, because if you use the path difference formula, that is, as it is a destructive interference, so it should be n plus half lambda. N plus half lambda. If you use this rule, uh, you will be able to find out, and this is a second uh, interference, so it would be 2.5 lambda accordingly. So that's what you need to write, and you must also show the formula. You're using the formula, what the value you get, and also write about the destructive interference, or else you will not gain marks. And next, state the condition required for the formation of a stationary wave. This is the same question. Obviously, when two types of wave of the same type interfere with each other opposite in direction, they superpose and form stationary waves. Next, the sound from a loudspeaker is detected by a microphone that is connected to a cathode ray oscilloscope. Figure 4.1 shows the trace on the screen of the CRO. Okay, in the air, the sound wave has a speed of this, wavelength of this much. The loudspeaker in B is held above a vertical tube. Okay, we are missing one question. Okay, so this question is missing, so that's not necessary to do. It's question C basically. So the first question is calculate the vertical distance between A and B. In order to calculate the vertical distance between A and B, some informations are given. The wavelength of sound from loudspeaker is this much. The sound that is heard becomes much louder when the liquid surface reaches level A, and the next time the sound much becomes louder when it reaches B. So it means there is a node at these 2 points. There are nodes. So the waves are something like this. The waves, the wave is something like this. So now we need to find out the distance between A and B, and it is actually the distance between two nodes, and this is like half of the wavelength, and we knew the wavelength was of 0.18 meter, so half wavelength lambda was 0.18. So if you divide 0.18 by 2, the distance would be 0.09. But then in question 3, they said that the mass of the liquid flowing was 6.7 gram per second, and the cross-sectional area of the cylinder and the density, everything was given. So first of all, we need to find out the volume. So the cross-sectional area was given in centimeter square, and our value, this 0.09 was in meters, so we converted that to about we convert that value to centimeter. That would be 9 centimeters, and the volume should be 13 multiplied by 9. Cross sectional area multiplied by height would be 117 centimeter cube, and then this value would be used with the density to find out the mass. That would be 92.4, and the time taken would be 92.4 divided by 6.7 to find out. We get 13.8, or it can be rounded up to 14. Next, what is coherence? Coherence is obviously the phase difference between the two waves should be constant. Whenever the phase difference are constant, that time the two waves are coherent. Next question was about the two waves P and Q meet at point, and they're in phase superimpose. And wave P has an amplitude of 1.5, intensity I, but when the waves meet, the resultant wave has an intensity of I3. So what would be the amplitude of wave Q? So we need to find out the amplitude of wave Q. Now remember that the resultant wave is found by adding the amplitude, sum of the amplitude. So when intensity was I, the amplitude was 1.5. And why is it square? Because we know, we have studied in previous wave chapter, that intensity is square of amplitude. And when the resultant intensity is 3I, and the amplitude of the resultant one would be amplitude of Q. This is the amplitude of Q plus the amplitude of P. That should be square of that. So if you, this I should be crossed off, and if you find out A, that would be, if you make A the subject, that would be 3 times 1.5 square, and the root over of this one subtracted by 1.5, that would be 1.1. 1.1 is the answer. The next question is about C, where there is a double slit, and they asked us to determine the slit difference A. Actually, all the values are given. We use the formula lambda equals to AXD. If you make A the subject, it is lambda D divided by X, and the lambda is given 680 nanometer converted to meter. And the distance D, if by using the graph, if we see, if when the distance is 2, value of X is 4 millimeters, so we convert 4 millimeter to meter. We put these values, we get our answer. Done. If we use a shorter wavelength, then how will it affect this graph? Now, if you see the connection between wavelength and the separation of fringes, if we decrease the wavelength, then the X would also decrease. So therefore, the graph that would be produced would be always below this original graph. So it can be anywhere, just like this, or it can be like this, or it can be like this. It depends. You can give anywhere. But for an example, here they use 680 nanometer, and a shorter wavelength could be about, the shortest wavelength could be about 400 nanometer. This is the shortest wavelength. So if you use the shortest wavelength to find out X, you can find out the value of X. And then accordingly, if you make X the subject, and then it would be lambda D by A, and the value of lambda would be then 4 times 10 to the power negative 7, and multiplied by D, that would be 2, because we are trying to find this out at 2. And A, that's what we found, 3.4 times 10 to the power negative 4. If we find it out, this value would be 2.3 millimeters. So the whatever line you give, it should be in between this 4 and 2, but it can't go below 2, not here, because if it goes here, then it would be wrong, because wavelength of light cannot go below this value. Next question is about, they told us to find out the separation D between the centers of the adjacent slit, and angle is given. So the formula that works with this is D sine theta equals to n lambda. And where you make d the subject, it would be n lambda by sine theta, and this theta should be half of 68 divided by 2, and the value of n should be 3 because they said this is the third order, so the value of n should be 3, and lambda should be 6.5 times 10 to the power negative 7. So if you put all the values together and calculate this, that would be 3.5 times 10 to the power negative 6 is your answer. When the red laser light is replaced with a blue one, we know that blue light has a shorter wavelength than red light, and as a result, the angle between the third fringe diffraction would also decrease, because we know that if we decrease the wavelength, then the angle will also decrease because they're directly proportional. The next question is about time-based setting. They want the time-based setting in second per centimeter. A CRO is given, and if you notice the CRO carefully, to complete one wave, it takes about 4 centimeters. So 4 centimeter is 1 lambda. A frequency was given about 5000 hertz. So we can find out the time period, where 1 by 5000 would be 2 times 10 to the power negative 4 seconds. So 2 times 10 to the power negative 4 seconds is taken for one wave, or it is equivalent to 4 centimeter. Then what would be 1 centimeter? Using unitary method, 1 centimeter would be 5 times 10 to the power negative 10, negative 5. So this is your answer. In the next question, they said that the intensity I was used for this graph. This graph was found by intensity I. Now, and the amplitude here, according to this, if you find it out, it was about 1 centimeter amplitude. But when they increase the intensity to 3I, what would be the amplitude? Say, and they also told to draw and sketch this graph. If you see this unitary method, if I is 1 square, then 3I should be how much? X square. So if you find x square would be 1.7. X value of x means the new wave will have 1.7 frequency. So if 5 boxes are equivalent to 1 centimeter, then 1.7 would be 4 boxes. This is the point where the graph will reach peak, like this, and like this. This is how you sketch the graph. The next question asks, explain why the bright fringes is produced by the waves. Obviously, we are having constructive interference. That's why. And then another question asks, what is the distance d? Basically, you know the slit differences, you know the wavelength. Um, the fringe difference is also known, so you just use the formula where the fringe difference x would be equals to lambda d divided by a, and therefore you put inside all the values. The lambda was 6.3 times 10 to the power negative 7 times d was about, sorry, there's a mistake, they told us to find d. Let's write it again. Write the main formula first. Lambda equals to axd, so d should be equals to ax lambda. So the value of a, 3.6 times 10 to the power negative 4. The value of x is 4 times 10 to the power negative 3, and the lambda is 6.3 times 10 to the power negative 7. If you do this calculation properly, you will get the value of 2.3. The last question told us to draw a graph to show the variation of x, the fringe differences with lambda. Obviously, we know that lambda equals to axd, and the lambda is directly proportional to fringe difference. So if you increase lambda, fringe difference increases. But the fact is that when the lambda is 400,
the will the fringe difference be zero? Is it possible? It's not actually possible. When the lambda is 400, there is a value for fringe difference. There will be a value for fringe difference. So it will start with a non-zero x and it will go straight up. That's all.